Alrighty, this is a video on the molarity and dilutions review. So when we took the quiz on Thursday, if you realized on that day that, oops, I don't really know what's going on with molarity, or if you thought you were good until you got your grade back, this is a reteach, review, combination thing where I'm going to go over the answers to the review. I think we did this review in class on Wednesday, I think, but if you were behind on Wednesday, this probably wasn't super helpful to you. So here is a very thorough video going over everything. First, number one, how many milliliters are in a liter? There's no real way. I mean, this is just something you either know or you don't. There are 1,000 milliliters in 1 liter. That's just something that you gotta know. That's not going to be written down for you anywhere. That's just, that's how it is. If we want to convert between milliliters and liters, which we will have to do on the quiz and on this review, the way that we do that is, for example, let's say we have 250 milliliters and we want to convert that to liters. We can divide by 1,000. And that will give us 0.250 liters. And you can see that when we divide by 1,000, really what we're doing is we're just moving that decimal 3 places. So we can see how that becomes from 250 to 0.250. Number 2, what is the molar mass of sodium chloride? If you're thinking, this isn't really a molarity problem, that's right. It's not. It's just straight molar mass. So this is when we use the periodic table, we find the atomic weights of sodium and of chlorine, and we're just going to add those together. So this is 22.99 on your periodic table and 35.45 on your periodic table. When we add those two numbers up, we get 58.44, and our unit for molar mass is grams per mole, so that is our answer there. 58.44 grams per mole. We use molar mass, by the way, to convert between grams and moles. So if I'm given an amount of some kind of a substance in grams and I want to do molarity calculations with it, well, in order to plug that amount into any of my molarity formulas, it's got to be in moles, not grams. So the way we convert grams to moles, remember, is we take the mass in grams and we divide that number by the molar mass of the substance. So if this were sodium chloride, we would divide the gram amount by 58.44, and that'll give us the moles, and then we can use that in our molarity calculations. That's going to come up a bunch in this review. Number 3, define molar mass. This, as we know, is the number of moles. Oops, it's not right at all. The number of grams in 1 mole. Or we can say that it is, we can say that it's the mass of 1 mole of a substance. Remember that a mole is another way to say 602 sextillion particles. And that word particles can either mean molecules or it can mean atoms, depending on whether we have a compound that we're talking about or just an element. Number 4, how many moles of sodium chloride are in 2 liters of a 1 molar solution? So now for the first time we have a molarity question. This big M means molar or molarity. We can say that this is a 1 molar solution. That tells us the concentration of the solution. Molarity is a unit of concentration. Molarity is a unit of concentration. And if we have something that is 1 molar, that means that we have 1 mole of solute. Let's do it like this. 1 molar means 1 mole of solute for every 1 liter of solution. That's what 1 molar means. When you see this 1m, that means that's telling you the number of moles of solute, in this case sodium chloride, the number of moles of solute that are dissolved in every 1 liter of solution. So if this was a 2, if this was 2 molar, that would mean that we have a 2 molar solution. That's 2 moles of solute dissolved in every 1 liter of solution. So molarity is like a ratio between amount of solute and amount of solution. Okay, so then let's use that understanding of molarity to answer this question. We want to know how many moles of sodium chloride are in 2 liters of a 1 molar solution. Well, if we know that we have 1 mole of solute in 1 liter of solution, and we want to know about 2 liters of that same solution, we should be able to see that this is pretty clearly going to be 2 moles. We should have double the amount of solute if we have double the amount of solution. So then our answer here is just 2 moles. Two moles of our solute, which, like I said, in this case is NaCl, sodium chloride. If this is confusing to you, I have another way of thinking about it, and that is to use the formula. So I want to show you a different way to think about this. That's the formula that you should have written on your periodic table. You should have this written on your periodic table. Capital M for molarity equals, or is equal to, the number of moles, right? Moles divided by, over, liters of solution. And what we can do is, when we're being asked about how many moles, or what's the volume, or what's the molarity, we can just plug in numbers to this formula. So the numbers that I have 2 liters, so I know the volume of my solution is 2. I know the molarity as well, that's 1. And so now you can see that we're really just solving for x here, because we know the molarity, we know big M, and we know the liters. So if we have 2 of those numbers, now we can solve for x. And I'll show you, show you 2 ways to solve for x. This is all about options. There's a lot of ways to do things in this unit, so you can pick the thing that makes the most sense to you. One, we can just think about it. Look, if we have 1 equal to some number over 2, that's like, okay, what number divided by 2 equals 1? We know that any number divided by itself is 1. So then, just right off the bat, we know, oh, that's 2. Right, 2 divided by 2 is 1. That can't be anything else other than 2. But if you are having trouble seeing that, then you can also do it this way. You can multiply both sides by 2 liters, right? Because remember, we want to get x by itself, and right now x is not by itself. It's being divided by 2. If I want to undo that division, I have to do the opposite of division, which is multiplication in this case. And that means that now I can cancel these 2 L's, right? But this is an equation, so I need whatever I do on the right side, I have to also do on the left side. So I have to do 2 liters times 1 molar equals X number of moles, right? And these things don't matter because they're crossed out. They cancel each other out. And now, look, 2 times 1 equals x. So now you can you can punch in your calculator if you want, 2 times 1. But that's just going to be 2 moles, obviously. And that's our answer. So we get the same answer either of the 3 ways that we do it. 2 moles of NaCl. Moving on. Number 5 says that a beaker contains 500 milliliters of a 0.5 molar solution. How many moles of solute are there? This is very similar to number 4, but now our numbers are different, of course. Why don't you pause the video here and pick the method that I just showed you that you like the most, and then you can play and see if you got it right. So this is going to be 0.25 moles. If that's what you got, well done. If that's not what you got, hang in there. I'll show you why it's 0.25. I'll do the this way first. How about that? So right off the bat, I'm going to notice I have 500 milliliters. My definition of molarity is about liters of solution, not milliliters of solution. So I'm going to convert my milliliters to liters. I know that 500 milliliters divided by 1,000 gives me 0.5 liters. And so that's 0.5 liters of solution that we have here. And then I'm going to look at my my molarity here. This means that there are 0.5 moles of solute in every 1 liter of solution. Remember, that's what that big M means. It tells us the number of moles dissolved in 1 liter specifically. In this beaker that we have, we don't have 1 liter. We only have half of a liter, right? So then all we have to do is instead of 1 liter right here, I'm going to write 0.5 liters. I hope that we can see that 0.5 is half of 1. And if we have half the amount of solution, as we do in our definition, right, then we should also have half the number of moles of solute. So that's going to be 0.25. That's 0.5 divided by 2. Right, because this was divided by 2. So that's 0.25 moles of solute. Okay. Let's do it a mathier way. So if we have, using the formula here. So that's big M equals moles divided by liters. I know my molarity is 0.5. I know that my liters is also 0.5. And now I am solving for x. So for this, I'm going to multiply both sides by the thing on the bottom again. So multiply both sides by 0.5, because I'm trying to get that x moles by itself. That allows me to cancel these out. Remember, whatever I do on the right side, I have to do on the left side as well. So that's 0.5 L times 0.5 M equals x moles. If you punch that in your calculator, 0.5 times 0.5, it'll tell you that there are 0.25 moles. And that was the same answer that I got over here. So that's how we get 0.25 moles. Number 6. This time, they give us grams. Say we dissolve 80 grams of sodium hydroxide in water. We want to know how many moles this is. Grams, moles. I don't have anything about liters here, and it's not asking anything about molarity. This is just a straight, it wants to know how many moles of sodium hydroxide is in 80 grams. So this is like what we were doing. We've been doing this for weeks now. This is just a gram to mole conversion. We see that we wrote this up here, and it's also on your periodic table, that if we want to convert grams to moles, all we need to do is divide our mass by the molar mass. So I need to calculate the molar mass of sodium hydroxide. Sodium hydroxide is NaOH. Na on the periodic table is 22.99. O is 16. And H is 1.01. I add all those numbers up, I get 40, but that needs a unit on it because all my numbers do. 40 grams per mole. Grams per mole is a unit for molar mass. And remember that molar mass describes the mass of 1 mole of any substance, or the number of grams in 1 mole. All right, so 80 grams, I want to convert that to moles, so I'm going to take 80 grams. I'm going to divide by my molar mass, which I just calculated to be 40 grams per mole. Punch that in my calculator, 80 divided by 40, and then I'll spit out 2. So this is 2 moles that I've dissolved in the water. Number 7, this is a question about the definition of molarity. It says that we are told that a solution has a concentration of 2.5 molar. Remember, that's how we read that big M. That's molar, 2.5 molar. We want to know what this means. You think about it for a second. Pick your answer. If you were in between B and C, that's good. C is technically wrong because there's a weird grammar thing in there. I messed up while I was typing this worksheet. C should not even be there. B is the answer that we're looking for here. There are 2.5 moles of solute dissolved for every 1 liter of solution. That's what the M means. Every time you see the M, you might even, like, in your head say moles per liter. And that's what the big M means. It tells you the number of moles in 1 liter, or for every 1 liter of solution. Number 8 is building off of number 6, because we are dissolving 80 grams of sodium hydroxide. So it's the same amount of stuff, but now it's telling us specifically how many liters of solution we're making when we dissolve that 80 grams. And then we want to know the molarity of the solution that we just made. So, like we calculated in number 6, this is, we know that 80 grams of sodium hydroxide is equal to 2 moles of sodium hydroxide. And we also know that this is 2.5 liters of solution. If you are having trouble keeping track of all the numbers in these problems, it might be helpful to, like, underneath every problem, or like on the right side, or like somewhere, like, have a routine, you know, for writing down all the information that you know, and you can plug in, like, you can just list like 2.5 liters, 80 grams, 2 moles, and then figure out, like, based on the wording of the question, what we're looking for, right? In this case, we're looking for molarity, which is big M, and we can put like a question mark there, right? And then you can check all of your conversions that you know, right? Milliliters to liters, grams to moles, moles to grams. You can check your dilution formula, you can check the molarity formula, and you can try to figure out, based on that, which formula we're using here. In this case, we want to know molarity. I know that when we have moles and liters, that's all we need to solve for capital M, molarity. So right off the bat, I can just do this. I can just say 2 moles divided by 2.5 liters, and I can just plug that into my calculator. .8 molar is what I get. For an extra little challenge, pause the video and write down what this means. 0.8 molar. So this should be 0.8 moles of solute per, or for every, liter of solution. Moving on. Number 9, how many liters of 0.5 solution can you make by adding adding water to 2 liters of 1 molar solution? So, This is our first dilution problem, and I want to show you how I know that this is a dilution problem. There's two ways that I know. First, it says that I'm adding water to a solution that already exists. Anytime I'm adding water to a solution, that means that I'm like watering it down. You can think about like when you are drinking a nice beverage and then you add water to it, that makes it taste less sweet or less whatever you're drinking. That's because you're diluting it. You're decreasing the concentration of the sugar or whatever it is that you're drinking. So that is a dilution problem. And every time you have dilution happening and you're being asked about the new volume or the new molarity, you're going to want to use M1 times V1 equals M2 times V2. That is a formula that you should have written on your periodic table. If you don't have that written on there, then add it now. And then remember how to use it. First, we're going to identify all of our variables here. So this says how many liters of 0.5 molar solution can you make by adding water to 2 liters of 1 molar solution. For these dilution ones, I like to imagine that I have 2 beakers, and it helps to think about like what's in each beaker. Anytime you see this kind of stuff, where you say 2 liters of 1 molar solution, you know that that's in 1 beaker. Right? So in one of my beakers, I know that it's 2 liters, and I know that it has a molarity of 1. My other beaker just has water in it. And this water is going to be poured into here to dilute the existing solution. Let's see, hold on. So then time passes, right? And now we have more solution in there because we added water. And we know that the solution we were trying to make has a molarity of 0.5. 0.5 molar. And we want to know the new volume because it's asking how many liters. We don't know how many liters. That's what we want to figure out. So we can see that this is the original solution, and this is the new solution. So that should help us identify which numbers go where. If this is overly tedious and I'm going into too much detail, I'm sorry. You can fast forward through what I'm doing and get the stuff that you need. 1 molar is the original molarity here. The original volume is 2 liters. Molarity 2 is 0.5 molar, right? Because that's what we're trying to make. And we're trying to solve for the new volume. So what we're going to do is we're going to take our formula here and try to rearrange it to solve for V2. The way that we do that is we can divide both sides by M2. And you can see that that lets us cancel them on this side, so then the V2 is by itself. And now we can just plug in numbers because we already know what all of these numbers are. All right, M1 is 1 molar. V1 is 2 liters. And M2 is 0.5 molar. So now into my calculator, I'm going to type 1 times 2 divided by 0.5. And that gives me 4 liters. And there we go, that's our answer. I won't draw the pictures for each. Actually, maybe I will. I kind of like the pictures. And you might like them too, which is the main reason that I'm going to draw them, to help whoever's watching this. Number 10. How many moles of sodium hydroxide, NaOH, are dissolved in 0.2 liters of 2.5 molar sodium hydroxide solution? I'll tell you that this is similar to numbers 4 and 5. So look at what you did up in 4 and 5 and give number 10 a shot now. All right, here we go. So I am trying to figure out how many moles. I know that I have a solution that is 0.2 liters, and I also know the molarity is 2.5 molar. When you see that you're solving for moles and you have liters and molarity, you know that we can just use this equation here, or this formula. Capital M equals moles divided by liters. Capital M is 2.5. It's molarity. Moles, that's what we're solving for. That's X. Divided by 0.2 liters. So then to solve for that X, remember we can multiply by the denominator, the thing on the bottom. That lets us cancel it, but we have to do it on both sides. And now this is 0.2 liters times 2.5 molar equals, in this case, 0.5 moles. And of course, you could do this the other way, right? Where the molarity, the capital M, tells us the number of moles in every 1 liter of solution. And then we're not being asked about how many moles are in 1 liter, right? That's not what the question wants to know. It wants to know how many moles are in 0.2 liters. So then we need to figure out like how many times 0.2 goes into 1, or like what's 1 divided by 0.2. And we'll see that it's a scale factor of 5. So we have 1/5 of a liter. If we have 1/5 of a liter, then we should have 1/5 as many moles as well. Right, so that's 2.5 divided by 5 gives me 0.5 moles. So that's the other way that you could work it out. Number 11, how many grams of sodium hydroxide are dissolved in 200 milliliters of a 1 molar sodium hydroxide solution? So give this one a shot. This is similar, but this time it's asking about grams. So pause the video and try it now. Okay, so just like before, I'm going to start by listing what I know. All right, I know that I have 200 milliliters. I also know how many liters that is. Anytime you see milliliters, you pretty much need to convert to liters. That's a good rule of thumb. So this is 0.2 liters. Remember, you can divide by 1,000, or you can move the decimal 3 places to the left. I also know the molarity. I know this is 1 molar. And I want to know grams this time. Well, I can't get to grams right from liters and molarity, but as I know from the last one, I can get to moles. So I'm going to use my this formula again. So I know this is 0.2 liters. Figure out how many moles that is. This time, since it's just 1, it's pretty easy to see that this is just going to be 0.2 moles, because 0.2 divided by 0.2 is 1. So that's 0.2 moles of sodium hydroxide. But it's asking about grams, so I need to convert to grams. How do we convert to grams again? Look at your periodic table. That's right, we multiply by the molar mass. So I need the molar mass of NaOH again. which is 40 grams per mole. We know that from previous problems. So I can do 0.2 times 40. And that gives me 8 grams. Here's my answer. Okay, I'm going to work through the last ones on this page, and then I'm going to take a break. Maybe I'll even upload this for those of you who've been waiting for it. Number 12, how many molecules of CO2 are there in a mole of CO2? This is not even a molarity question or even a molar mass question. This is going way back to the definition of a mole. In 1 mole of any substance, like I said up here, 1 mole is 602 sextillion particles. So whether it's asking about atoms or molecules, this is going to be 602 sextillion. Or if you prefer, 6.02 times 10 to the 23 molecules. 13, molar mass of copper. You know this one. 63.55 grams per mole. Get that straight from the periodic table. 14, if I have 250 mils of a 1 molar solution and then add an additional 250 milliliters of water, what is the new molarity? As soon as you read these words, add an additional 250 milliliters of water. If we're adding water to a solution, this is a dilution problem. Guaranteed. Well, and if it's asking about the new molarity. I guess there's that. So this is a dilution problem. So it's time to list my variables. What do I know? It's telling me that I have 250 mils of a 1 molar solution. That's what I'm starting with. That's what I have. That's what I possess. So my volume is 250 milliliters. You can convert that to 0.25 liters if you like. But actually on dilution problems, you don't have to convert to liters if you don't want to. My original molarity is 1 molar. And M2 is what we're solving for, because it's asking about what's the new molarity, so we don't know yet. V2, the volume at the end, is going to be 250 mils plus 250 mils, gives me 500 milliliters. Or if you like, you can do 0.5 liters. And now I will write my formula and try to rearrange for the thing I'm solving for. Again, I'm solving for molarity, so I'm trying to get M2 by itself. I can do that by canceling the V2 out, by dividing it on the right, but I can't do it on the right without doing it on the left, so that is M1 times V1 divided by V2 gives me M2. Then I can just plug these numbers into my formula. By the way, all the work that I'm showing, everything that I'm writing down, I would expect you to show me on the quiz. So then when I plug that into my calculator, I'm going to get 0.5 molar. If you're wondering why I don't need to convert to liters on dilution problems, it's because, well, first of all, try this. Punch this one into your calculator, 0.25 liters divided by 0.5 liters. And you'll see you get the same thing. You get 0.5. And that's just because 250 divided by 500 is the same thing as 0.25 divided by 0.5. It's the same ratio. right? One is half the other, right? So it doesn't matter what number. I mean, it could be 3 and 6, right? It doesn't matter what unit of volume you use as long as you're consistent across the measurements. If I just lost you, that's fine. Just like, just either decide to not convert to liters or to convert to liters if it makes more sense to you to just always convert to liters. It doesn't make a difference. Number 15, try this one yourself. Okay, here we go. If 100 milliliters of water is added to a 200 milliliter sample of 2 molar solution, the new molarity is... this is another one, right, where we have water being added to a solution. So this is going to be a dilution problem. My original molarity is 2 molar. My original volume is 200 mils. What is my second volume? It's going to be 300 milliliters, right? If you said 100, remember it's being added. It's being added, so we have to add our volumes. 100 mils of water plus 200 mils of solution gives me 300 milliliters of solution. And again, I'm solving for... That's the weirdest question mark I've ever... we want to figure out the new molarity again. So this is going to be, again, M1V1 divided by V2 to give us M2. Plug these numbers in, 2M times 200 milliliters divided by 300 milliliters. 2 times 200 divided by 300 gives us 1.3 molar. 1.3 repeating, but you can round to 3. If you want to, if you prefer that, I'm fine with that. I don't really care about rounding that much. So there we go. That's the first page of the review. I don't know if I'll have the second page up tonight. I might have to do it tomorrow just because it's getting somewhat late and I would like to have a life. Anyway, if you were waiting on this video, I'm going to email you directly that it's up, so that way you can check it out tonight. And let's see, how long was this? Well, 40 minutes. Okay, yeah. So I'm glad that I'm not doing the second half tonight because I don't want to ask you to watch an hour and a half of chemistry. This is plenty. What you should really do now that you've watched this is try to finish the back if you haven't already, and then you can check your work against the key on Google Classroom. Or if you get super stuck and you don't understand the key, just wait for my video. It'll be up tomorrow. Yeah, it'll be up tomorrow. So, thank you for watching, and I hope that was helpful.